Hey guys, welcome to your video lesson for today. I hope that the audio is better than last time. I got a different microphone, so hopefully it's going to work a little bit better. We are starting a new chapter today, so we're going to talk about a little bit of review stuff. Slope of a line is what we're really going to focus on today. We're going to talk about how to identify slope of a line from points. We're going to talk about how to identify it from a graph. We're also going to talk about slope-intercept form. All of those three things are review. But the video is here and you can review the information. You also have a homework assignment that goes along with it, okay? So let's get right down into it, all right? First of all, what is slope? Okay, slope is a measurement of how fast a line is going up or down, all right? So in very general, it's a measurement of how fast a line is going up or down. We always want to think of slope as rise over run, okay? It's the change in the y-coordinates, which we get by doing subtraction, and divide that by the change in the x-coordinates, which we get by doing subtraction as well. Remember, rise is up and down, right? Which is, if we look at a graph, that is our x and y anyhow. The run is left and right, and that's left and right on a graph as well. So it makes kind of sense. So you think of it as rise over run. Okay, also I want to make a point to stop and pause this video if you need to catch up with notes. I just don't want to make this video 25 minutes long, okay? Alright, slope, we always read it from left to right on a graph, and so there's some questions that we can look at just by looking at this graph, okay? What is the slope? Is it positive or is it negative? If we look at the graph from left to right, we notice that the graph is a positive slope, because as we go from left to right across, that slope goes up, alright? So we have an uphill battle, and our slope is positive. Okay, if it goes up, our slope is positive. If it goes down, our slope is negative. Next thing we want to talk about is, well, what is our slope? Okay, what is our slope? And when we do that, what we want to do, as you kind of remember, so we look at where this line crosses intersecting grid marks. Where does the line cross places like that? So the first place I notice is right here. And we always want to think of rise over run. So when does that line cross intersecting grid marks again? It crosses there and there. So what is my rise? How far do I go up? I go up 1, I go up 2. So I got 2 over, what's my run? 1. I go to the right 1. And as I go through that, 1, 2 over 1, 1, 2 over 1, that's consistent all the way across the line. Okay? So my slope is 2. Okay? And I think that's all I got on here. Alright, next thing. Look at the line again. Find the slope of the line. So again, we want to look and see where this line crosses intersecting grid marks. I find it's crossed there and there. It's going to be a positive slope because it's going uphill. And I go up from here to here, so that's a rise of 1. And I go right 1, 2. So I got a slope of 1/2. And if I look, I go up 1, right 2, up 1, right 2, up 1, right 2, and that follows the entire line. Okay, so let's look at a few more here. Slope of this line. I know for sure that this line is going to be negative because it goes down. Alright, so where does it cross intersecting grid lines? First part I notice is there, so I go down. Where does it cross again? Right there. Alright, so down 1, 2, 3, so that's negative 3 over, it goes right, 1. Negative 3 over 1. Let's see if that's consistent. Down 1, 2, 3, right 1. 1, 2, 3, right 1. So down means negative, and to the right means positive 1. So negative 3 over 1. We can simplify that to just negative 3. Okay? Let's look at the next one here. Again, this is going to be negative, so because it goes down. Alright, so intersecting grid marks. I find it to cross here. Next spot crosses there. So I go down 1 and right 1, 2, 3. So this is the slope of negative 1 over 3. Let's see if that's consistent. I go down from this point now, down 1, 1, 2, 3, yep, 1/3. So I have a slope of negative 1/3 for that line. Okay, so slope formula. If I don't give you a graph, how can you find it when we are only given 2 points, an x and a y coordinate? Given 2 of those, okay? First of all, m stands for our slope, which is something you should probably remember from slope-intercept form, all right? the formula is y2 minus y1 divided by x2 minus x1. All right, so we take our x's and y's and we label them. So this is, if I guess we can go into an example here. We want to label them. All right, we want to label them x1, y1, x2, y2. The reason we do that is because now I will not mix up this formula. I know where everything goes. So if I'm going to start this problem here, okay, I'm going to say m is equal to y2, so my y2 is 5, minus y1, which is 2, divided by x2, which is 5, minus x1, which is negative 3. Don't forget, it's always subtraction, and carry your negatives with you. So I got 5 minus 2, which is 3, over 5 plus 3, which is 8. So I have a slope of 3/8, which means if I'm going to be on a graph, I would go up 1, 2, 3, right, 1, 2, 3, 4, 5, 6, 7, 8, and that's a very rough drawing, but my slope would look something like that, okay? Rise over run would be 3/8, okay? Next example here we'll do real quick. M is equal to, again, I got x1, y1, x2, y2. All right, so take a look. y2 is negative 8 minus y1, which is negative 4, over x2, which is negative 2, minus x1, which is negative 3. So I got negatives all over the place. I'm going to change these to addition right away. So I got negative 8 plus 4, which is negative 4, over negative 2 plus 3, which is 1, which gives me an overall slope of negative 4. Okay? Whenever I graph, I want to think of it as a fraction, so I can think of rise over run. So again, this is still, if this is my graph, and let's just say I start out from this point here, I would go down 1, 2, 3, 4, and right 1. My slope would look something like that. That's a real rough drawing, but just so you get an idea. Okay, couple things here. Draw a graph that has a negative slope. We already talked. Your graph should look like this. Okay, and this is building up to something a little bit more specific here. Obviously, that's a negative slope. Draw a graph that has a positive slope. That's going to be uphill. Okay, now, things that we need to think about a little bit harder. A graph that has a slope of 0. A slope of 0 means it is measured and it's flat. That is a horizontal line. Horizontal. Horizontal lines have slope of 0. Okay? Draw a graph that has an undefined slope. This is what I want you to think about. Undefined is so steep that we can't measure it. It is a vertical line. Okay? So things that are undefined slopes are vertical lines. Okay? So, just some things to keep in mind. Positive, negative slopes and horizontal slopes are flat. Vertical lines have undefined slope. Alright, moving on. Next thing you're going to hear about is this thing called rate of change. Okay? All it is a measurement that shows, on average, how something changes over time. What it really comes down to is that it is slope. Rate of change is a slope. Okay? So, let's get into an example real quick. Alright? Let me just get rid of this, and we'll go down. Alright. So, in 2005, the population of Super Awesome Stan was 2,500. When people realized how awesome Super Awesome Stan was, more people moved there. In 2010, the population was 7,500. What is the rate of change during that time? Alright, what you got to do is come up with X, Y values from this problem. Alright? Remember, X is always an independent value. It's always time. So in the first sentence, we have 2005 mixed up with 2,500. 2005 is a year. This is a measurement of population, so we're going to use that. So my first value, I'm going to extend this here. My first point is X value of 2005 and a Y value of 2,500. Okay? The next one is a measurement of time again in another population. So my next point is 2010 and a measurement of 7,500 for the population. Alright? Now, this is nothing more than my first point and my second point. So this is my x1, y1, x2, y2. Alright, let's calculate the rate of change, because remember, that's just a slope. So y2 is 7,000. My m, which is rate of change, m is equal to 7,500, oh boy, 7,500 minus my y1, which is 2,500, divided by 2,010 for x2 minus 2,005 for x1. So subtracting the top, I get 5,000 in my numerator, and subtracting the bottom, I get 5 in my denominator. Well, that simplifies to 1,000 per year. Man, things are flying over the place here. 1,000 per year. 5,000 over 5 is 1,000. Okay? So I have a slope of 1,000, which means every year 1,000 people moved to super awesome Stan. Alright, so that's rate of change. Next thing we're going to talk about is something that should be pretty familiar, slope-intercept form. Y equals mx plus b. We are going to diagram what this formula is. Alright, m, we already talked about. M is your slope. Okay? We already talked about also that, and we talked about this in previous years, where m, we want to consider the way we move. How do I get from one place to the next? And we already talked about the way we do that is using that idea of rise over run. Alright? Rise over run. From a certain point, we go up so far or down, and then to the right. Alright? B, that is my y-intercept. Y-intercept. It's always my beginning. It's where I always begin graphing a graph. If I'm giving something that looks like y equals mx plus b, whatever this number is where I start on the y-axis. That vertical line that goes through the graph, this one right here. Okay, x and y, this is going to become important in 2 days. Alright? X and y are points on stay there, line. Okay, x and y are points on the line. Points on the line. If you can't read that, I'm sorry, I don't know what's going on my screen. X and y are points on the line. Alright, so let's figure out how we're going to use this here. Graph the following. Remember, this is our y-intercept where we start. The y-axis is right here. We always start on the y-axis. So, -1 is where we start. -1 is right there. My slope, my m, my movement is 2 over 1. Remember, we can write any number as a fraction to make it look like rise over run. So that means I go up 1, 2, and to the right 1. Up 1, 2, and to the right 1. The more I do this, the more accurate I get. So that line right there looks like this. Okay? That is a terrible line, but you get the idea. Alright? So, I'm going to get rid of this, and we're going to do the next one. Okay? Next line. My y-intercept is 5. 1, 2, 3, 4, 5 is right there. It's where I'm starting. And my slope is -5.7, so I'm going to go down 1, 2, 3, 4, 5. And to the right, 7. It's actually 1 off the graph here, so it's about there. And my line looks like that. And that's much better. Okay? Also, negative slope means we're going to have a downward line, right? Alright, cool. Next line here. I have y is equal to 2. Okay? Y is equal to 2. This is a special kind of line. This is a horizontal line. Okay? Horizontal line, y is equal to 2. It means it only goes through the y-axis. Only goes through the y. If you see y equals, it only goes through y. Where does it go through? It goes through 2. So it's a horizontal line right through +2. Okay? X is equal to -2. That's a vertical line. Okay? Vertical line. And it only goes through the x-axis. So if you see x equals, it only goes through x. And where does it go? It goes through -2. -2 is there. There's my vertical line. Okay, I'm going through this stuff kind of fast because it is review, but if you need to stop and pause it and get that information down, go ahead. All right, I think that's all I got for you there. Now what we're going to do is just give the equation of the line from the graph. All right, so let's look at this line first. Remember, we're always writing our equations in the form y equals blank x. Y equals blank x plus blank. Y equals mx plus b. So I got to find the slope first, which is something we've already done. So I'm going to look at where this line crosses intersecting grid marks. So it crosses there, and the next point it crosses right there. So I'm going to find the slope. I'm going to go up 1, 2, 3, and to the right 2. Okay, that gives me a slope of positive 3 over 2. So I got 3 over 2 for my slope. And where does this line cross the y-axis? Where does it cross? Right there, positive 3. So my equation is y is equal to positive 3 over 2 x plus 3. All right. So now I'm going to go back, get rid of this, and we're going to look at the next line. All right, I'll probably do just one more of these. All right, next line right there. Again, we're looking at y equals blank x plus blank, and we're filling in the blanks. So first thing I want to look at is my slope. Crosses intersecting grid marks there. Next time it crosses there. Next time it's there. All right, it's going to be a negative slope because the line goes down. So I'm going to go down 1, and to the right 1, 2. So I got negative 1 over 2 for my slope. So that goes here. Negative 1 over 2. Where does it cross the y-axis? It crosses right there. So I got a y-intercept of negative 1. All right, so that is today's lesson. What I want you guys to do is the worksheet that the sub is going to hand out to you right now. This video is on my website. If you need any extra help on this, please go ahead and feel free to view it at any time. Have a great day. I will see you tomorrow.